Bismillahirrahmanirrahim. Okay, this is a question number 6, and we will notice that in question number 6, nature of the fraction is improper. This is improper fraction because uh, denominator contains the terms uh, which are of lesser degree, and the numerator contains the terms with the greater degree. So x raised to power 5 is written in the numerator, and in denominator after the expansion, so we will notice that x raised to power 4 will be mentioned over there. So this is the difference from the other questions within the exercise, that this question is basically an improper fraction. So uh, we will convert fraction into improper fraction into proper fraction by showing the long division. X raised to power 5, x raised to power 4 plus 2x square plus 1. So once we will start the long division, x raised to power 4 will be multiplied by x. So it will become uh, x raised to power 5 plus 2x3 plus x, and signs will be changed. So this will be the remainder, and we will convert this fraction as quotient. The quotient is x, so we would write first x, then remainder, and finally the divider. So this will convert the improper into proper fraction. Now this part, which is we obtained after the long division, remainder over divisor, this is basically the proper fraction, and only this part will be partial fraction. This x will be indicated as it is in the answer. So that's why this negative sign is taken out common, and we will consider only the bracket portion, which is a proper fraction for the sake of uh, partial fractions. So I have written clearly that consider 2x3 plus x over x square plus 1 for the partial fraction. And for partial fraction, we have written 2x3 plus x over x square plus 1. It is proper fraction, and denominator contains repeated quadratic factors. So that's why we always write ax plus b form of partial fraction when there are quadratic in the denominators. So next will be cx plus d over x square plus 1 whole square. This is the format that we use for uh, repeated quadratic factors. Now, usual way is this, that we take up the LCM first. So we have taken the LCM, denominators are cancelled. 2x3 plus x and ax plus b, x square plus 1 and cx plus d are written. And next is that because there is no linear factor in the denominator, so we need to multiply, or we need to expand the terms of the right hand side. So we will do the expansion, and after the expansion, we will be noticing ax cube plus ax plus bx square plus b plus cx plus d. All these terms are expanded, and then we are going to compare the coefficients of uh, x3, x square, x raised to power 1, and constants from both sides. We will do the comparison of coefficients of the power of the variable. On left hand side, there is 2x cube plus x, so we would do 2x3 plus 0 time x square. We will add ourselves 0x square so that we can do the comparison. And the constant term will also be added as 0. So now the comparison of the coefficient x is to power 3 coefficient on right hand side is a, and on left hand side is 2. So both will be compared because there is no other term of x raised to power 3. So only a will be equated to 2. So this will be the equation number 2. Next, we would take up coefficient of x squares for the comparison. So on right hand side, we have only bx square. On left hand side, we have no term involving x. We have ourselves written 0 time x square. so that we can directly compare the coefficient of x square from both sides. So b will be equated to 0. So this will form, let's suppose, equation number 3. And finally, we will take up x common. So the term involving x on right hand side is ax and cx. So if we will take up common x, so a plus c will become coefficient, and on left hand side there will be coefficient of x, that is 1. So a plus c will be equated to 1. This will be equation number 4. And similarly, the constants will be equated to 0, b plus d. So 2, 3, 4, 5, these are the equations. And we have obtained answers of a and b directly from equation number 2 and 3. From equation number 4, we can derive the value of c, that it would become 1 minus a, and a is already calculated. This is 2. So 1 minus 2 will make value of c as minus 1. Similarly, from fifth equation, d will be equals to minus b. B was 0, so d will also become 0. Now, because a, b, c, d are calculated, we will simply put it into this equation for the sake of the partial fraction, for the completion of the partial fraction. So we will take up this equation substituting a, b, c, d values in this expression. So this is the expression. We are substituting values of a, b, c, d. So once the values are substituted, the partial fraction is completed, which was required. Now we just need to put it into original equation, that was equation number alpha, that we have formed on the very first process, that was obtained by the long division process. So for the sake of the long division process, whole number is x, and this part which is with enclosed within bracket, this was a proper fraction, and this proper fraction is converted into partial fractions. So we just need to place the answer of the partial fraction in this bracket, and I have rewritten this expression of alpha once again. And in this portion, I'm substituting the value of the partial fraction we have done on the above steps. So once the values are substituted, uh, of minus sign is outside the bracket, it will change the signs. And this is how the question will be completed. So it is an important question and has appeared in the board exams many times before.